Hey everyone, so for today's lesson, we are going to do lesson 1-7. This is our last lesson in this unit, and the last lesson is about translating words into algebraic expressions, but these are applications, so they're a little more trickier than the last lesson that we did. So we have our learning objectives is to translate English words into math language. Our learning objective to explain the process we use when translating words into mathematics. But these questions are going to be real life scenarios. So let's take a quick look at our do now. So let's take a look at today's do now, and today what we are asked to do is translate the following. So I want you guys to pause the video and try these two on your own. Okay, so this is what you should have got. I highlighted the keywords so I don't forget what I need to do. Triple number increased by 10. Let statement is there. Let x equal the number. Triple number means 3 times x, or 3 times your variable. Increase plus 10. For number 2, we have twice a number less than 4. Less than, I know, is subtraction, but I also know you need to switch the order. That's why I have my arrow there. So I remember. Let x equal the number. Again, my let statement. And this time, twice a number goes in back of the subtraction, 2x. Less than, again, subtract. 4 comes in front. So today's thinking is we are doing exactly the same thing from the last lesson. We're translating English into math, but these are the more applied types of questions, real life problems as we call them. So for the steps, you're going to take the same steps that we took in the previous lesson. You will need to read the problem multiple times sometimes and highlight and underline keywords. You will need to define your unknown. Let x equal, let n equal, your let statement. Here I included a bit more than before. Translate by using tables, charts, operations, numbers, and unknowns. So these are a mix of problems in which you may need to use multiple methods to try and understand it so you can solve it. At the very end, you always want to read your math and make sure it makes sense, right? So let's take a look at the first example and let's see how it is. For example number 1, what we are asked to do is we're translating these real life problems into some algebraic expression, and we're dealing with level 1. So these are the easiest types of problems that they could give us. So I'm going to read and I'm going to highlight. If S represents Sally's age and her father is 4 less than 5 times her age, then write an expression for her father's age in terms of the variable S. So I am lucky because at least I know that S is equal to, not the number this time. What does S represent? S represents Sally's age. So now we're moving away from let x represent the number. What are we looking for? We are looking to find an expression for her father's age. So how can I represent her father's age? What did they tell me about her father? So they said her father is 4 years less than 5 times her age. So I know less than means subtract. I know less than means we're going to switch. So what are we switching? We're switching the number 4 to the back. 5 times her age. Now who is her? Sally. So we're dealing with 5 times Sally's age. So how can I represent that? 5 times Sally's age would be 5s. So here is her father's age as an expression. Let's look at number 2. For number 2, Juan has $50 in a savings jar and is putting in $5 every week. Write an expression that shows how much Juan is saving. So first thing I'm going to do is do my let statement. Let, this time they didn't tell me a variable, so I'm just going to stick with our x. But what does x represent? I underlined it. Every single time you see this word, every, you see the word each, you see the word per, those words are telling you that that is your unknown. So what I don't know is how many weeks he is saving. So I'm going to say let x. So that's what my x is representing. every single week. It could be 1 week, it could be 10 weeks, it could be a whole year. So now that I have that, now I'm going to break it down more. So we're looking for Juan, how much Juan is saving. Juan equals. All right, so we know that Juan has $50 in his jar. So no matter what, he has $50 in there. And he is putting $5 every week. If he is putting money into the jar, is that $50 going to get smaller or bigger? Am I going to make more money or am I going to lose money? It only makes sense that we're going to be making more money because he's saving. How much is he saving? He is saving $5 every week. So 5 times X. This is my expression. He starts off with $50. This is his start. Every week he is placing $5 more. So in week 1, he's going to have $55. The next week, he'll have $60. The next week, he'll have $65. And the cycle continues. So let's take a look at the more challenging types of problems. Example 2. So for this example, we're doing the same thing. This time, these are our level 2 problems where we have to think just a little bit more. And most often, there's a part B, a part C question that we may need to answer. So for number 1, company A is offering Lisa $10,000 for the first month and will increase the amount each month by $5,000. So for the first month, she is going to get $10,000. And every single month or each month, she's going to get $5,000. Again, I'm looking for that word each because that each is going to tell me what's my unknown. So let me read what part A is. Write an expression that Lisa can use to determine how much company A is offering her. So first things first, let's do our let statement. Let X equal. What is X? I found that word each month. So the number of months. Okay, so X is my number of months. Again, I don't know if she's going to be there 1 month. She could be there 5 months. Now that I have that, now I'm going to break things down. So how much is company A offering? So in the beginning, this company is going to give her $10,000. So that's her starting amount, $10,000. That's what she's making the first month. And will increase the amount. So what does this word increase mean? I should have highlighted. Increase means we're going to be adding. We're going to get bigger. So every other month, she's going to make $5,000. So how can I represent that? 5,000 times X. And this is her expression. How much will Lisa have at 3 months? So now they're giving me how many months she might have, which means X equals 3 months. If I know what X equals, what can I do to the algebraic expression I already know? Yeah, I could replace it. So I know that X is equal to 3. I have an X here. I'm going to substitute. I'll put that into my calculator and evaluate. This is cash. So I must show my work. There's my math work to it. But this is a word problem, and word problems, we want a small sentence. So I'm going to say Lisa will have or will make $25,000 at 3 months. I usually, when I write my sentence, I usually read what it is they asked me for and I rewrite it in the same way. Let's take a look at the next question. So that one wasn't that bad. For number 2, in 2013, the United States Postal Service charged 46 cents to mail a letter weighing up to 1 ounce and 20 cents per ounce for each additional ounce. So I see the word per, I actually even see the word each, so I kind of already know that's my let statement. A, write an expression that can be used to determine how much you will have to pay the postal service. Okay, so first thing I'm going to say is my let statement. Let X equal, each is followed by the word ounce, per is followed by the word ounce, so I know we're talking about number of ounces. Now that I have that, now comes the hard part. Now comes us reading again and interpreting it piece by piece. The Postal Service, the U.S. Postal Service, charges. Okay, so the U.S. Postal Service is going to charge 46 cents to mail a letter weighing up to 1 ounce. For 1 ounce, I am going to pay 46 cents. But I have to pay an additional 20 cents per ounce. I have to pay plus an additional 20 cents per each additional ounce. And here comes the tricky part, because each ounce that we're going to pay 20 cents does not include the first ounce that we have already weighed in. So we have our X minus 1. Why am I subtracting 1 here? Because we have to take off the first ounce that they asked me to pay for. Again, this is one that's coming from a Regents that tricked everyone who did this, because you had to remember to take off that extra ounce. Once you have your expression, the next part is usually the easiest, because they're going to tell us to do some sort of evaluating. So how much will you pay or have to pay the U.S. Postal Service if you have a package that weighs 15 ounces? So they're telling me that X is equal to 15. Again, I know my expression is, wherever I see my X, I replace. At this point, I input it into my calculator exactly as it is. And this time, I am going to keep it in decimal form. The reason you're keeping it in decimal form is because you're talking about money. And money, we don't talk about fractions. So we want to keep it like that. So make sure you write your sentence. So we have, let's say, U.S. Postal Service will charge $3.26 for a package that weighs 15 ounces. So in quick summary, when asked to translate a verbal problem into math, you must start by identifying important keywords that will help you. Look for words like each, per, or every, which tells you what you're going to be letting your let statement be. Make tables if that helps, charts if that helps. Always define your variable and slowly break down the words and turn them into math operations, variables, and numbers. And again, the most important, read the math, make sure that it makes sense. So keep learning, keep growing, and review these because these are very tricky. All right, so I will see you guys in the next video.